So we have an open can here, and the air, the atmosphere that's being pulled down by the gravity of the Earth is pushing on the outside of the can. But since this is an open can, the air inside, that same air being pulled down by the Earth's gravity, is pushing out. And then we have this kind of equilibrium here where nothing happens to the can. Let's think about those molecules inside of the can and what they're doing. So we have molecules of air, the red are oxygen, blue nitrogen, there's some argon, carbon dioxide, and water vapor. And as they move around, when they're hitting the side of the can, they're creating pressure. That's the air pressure. And that's pushing on the can from the inside. Of course, on the outside, we have the exact same pressure, and that's pushing on the can. Every time those molecules collide with the can, they create pressure as well. So let's think about liquid water. We put a little bit of water in the can, and it sits at the bottom of the can, and then we have the air above it with those gas molecules moving around. But if we start heating those water molecules, so here we have, as a liquid, these molecules are moving around, but they're pretty much staying together. They're not getting too far apart. If we raise the temperature up, it will change from a liquid into a gas, and the water molecules will spread out. When they do that, they'll push all of those air molecules out, and all we'll have inside of the can is water vapor. Let's see that happen. The temperature increases. You can see the water molecules are spreading out, and they'll force the air out of the can, leaving just water vapor in the can. So now we flip the can over, put it in water. That seals the top so no air can get in, and we've cooled the can. And all that gas, that water vapor in there, changes back to a liquid very quickly. That's important because as a gas, the water molecules were hitting the side of the container and creating pressure. We still have air on the outside, molecules hitting the side of the container, creating pressure, but on the inside, we don't have the gas anymore. We have a vacuum because we've sealed the top when we turn the can over. And because of that, air pressure on the outside crushes the can.